Okay, we will start our session. In last lecture, we have finished our chapter number 5, and today onwards, we will start last chapter from this artificial intelligence. And one more chapter is remaining from our first session. Means this chapter is second last chapter of our syllabus. Okay. All are requested to join. सगळ्यांनी बरेच जण असं मला लक्षात येत आहे की तुम्ही लास्ट ना जॉईन होताय फॉर अटेंडन्स पर्पज ओनली. Those are doing such things. Okay, I will mark absent. Okay, those are present at from start of session. Okay, I will mark attendance of those students only. Okay. I have observed from last 2-3 lectures. Okay, those are joining late and okay, before 10 minutes they are joining and putting the roll number and leaving the classroom. Yeah, I will mark definitely absent for those students. I have taken the screenshot of same. Let we will decide who is joining late and I will find out those. Okay, if you have any problem, you can ask. Okay, otherwise we'll start our session. Okay, this one is the second last unit of our subject, robotics and artificial intelligence, and the last chapter from artificial intelligence. And this title of this unit is vision system for AI. Okay, why it is required vision system? Now we are going to discuss one by one, and first we'll know okay syllabus of this vision system for AI. Okay, in this chapter we are going to discuss machine vision. What is mean by machine vision, definition and system components, lightning techniques. After that, we are going to see the image processing fundamentals like edge detection, shape analysis, segmentation, object identification, template matching, cameras, camera specification and selection, and camera calibration. Okay, these many parts we are going to discuss this in this unit. Okay, we'll start with what is mean by vision, vision definition, and after that we'll go one by one. Lighting technique. There are different lighting techniques. Might be you have seen. Yeah, that this lighting techniques you have studied in physics. Might be in 12th also. You have studied this lighting techniques, which is used in our vision system. Now we will see one by one. Again, after that, first we should understood how that camera it works. Okay, while clicking on that button, what is process inside that occurred. Okay, सगळ्यांना माहित असेल तर सगळ्याकडे स्मार्टफोन आहेत. त्या स्मार्टफोन मध्ये कॅमेरा आहे. आता कॅमेरेच्या साईने तुम्ही काय करता तर जे काय आपल्याला लाईकली आणि अनलाईकली ओके those are likely environments or the we can say that likely photos are we are clicking with our cameras. Okay, similarly if you compare with our human, okay, eye are the okay our cameras or the visions of human body. म्हणजे आपल्या जर आपल्या ह्युमन बरोबर जर कम्पेअर करायचं झालं तर डोळे हे काय तर आपले विजन सिस्टीम आहे. डोळे म्हणजे काय तर ह्युमनची विजन सिस्टीम किंवा कॅमेरा ऍज वेल ऍज व्हिडिओ रेकॉर्डर. ओके, कॅमेरा आणि व्हिडिओ रेकॉर्डिंगचं जे काय काम करणार आहे ते ह्युमन मध्ये तर ते कोण करणार आहे तर आपले आय करणार. ओके, देन फर्स्ट वी विल अंडरस्टूड व्हॉट इज मीन बाय विजन. ओके, विजन म्हणजे काय आपण बघूया तर त्या ठिकाणी vision can be defined as the task of extracting information about the external world from light rays imaged by a camera or an eye. Okay, vision is nothing but we are saying that, okay, we are capturing. Okay, now only I have discussed. Okay, those are liking, म्हणजे जे आपल्याला आवडते असे पिक्चर आपण काय करतोय तर we are capturing with the help of camera or eye. Okay, that external world pictures or the images we can captured by camera or eye, that process is nothing but our vision. Okay, त्याच प्रोसेसला आपण काय म्हणतोय तर vision असं म्हणतो. Vision also referred in the literature as a computer vision or machine vision or robot vision. Okay, for this it is known as a machine vision or robot vision or computer vision also it is called. Okay, now in industries where we can use this vision system. आता ही vision system आपण कुठे यूज करणार आहे and what is the purpose and application of our vision system we are going to discuss. ओके, आता यामध्ये कशा पद्धतीने कॅमेरा काम करणार आहे आणि त्याचं फंक्शन काय असणार आहे हे आपण आता त्या ठिकाणी डिस्कस करणार आहे. ओके, नाउ इन एनी प्रोसेसिंग इंडस्ट्री, ओके, कुठलीही प्रोसेसिंग इंडस्ट्री असेल, इनसाइड दॅट कन्वेयर आर देअर. ओके, कन्वेयर असणार आहेत. ओके, अँड ऑन दॅट कन्वेयर डिफरंट ऑब्जेक्ट्स आर मूव्हिंग. ओके, तर वेगवेगळे ऑब्जेक्ट किंवा एखादी प्रोडक्शन लाईन असेल तर त्यासाठी तर त्या कन्वेयर लाईन वरून काय असणार आहे तर सेरीज ऑफ प्रोडक्ट्स आर मूव्हिंग. म्हणजे त्या ठिकाणी काय असणार आहे तर भरपूर असे प्रोडक्ट असणार आहे, ते एक प्रोडक्ट ह्या कन्वेयर वरून काय असणार आहे तर मूव्ह होत राहणार. ओके, आता मूव्ह होत असताना टू फाइंड द डिफेक्ट ऑन दॅट ऑब्जेक्ट्स वी नीड दिस vision system. Okay, in vision system, okay, we require illuminating light source. Okay, suppose this one is the object. I want to identify the object specification. For that we require the illuminating light source. Again, camera and the lenses. Okay, this one is the camera and lenses. Image processing library, we require image processing library. We require softwares. Okay, आपल्याला सॉफ्टवेअर लागणार आहेत. नाउ द फ्रॉम कन्वेयर ऑब्जेक्ट्स आर मूव्हिंग. ओके, ऑब्जेक्ट काय असणार आहे तर मूव्ह होत असणार. नाउ सपोज एनी डिफेक्टिव्ह कॉम्पोनंट्स आर ओके प्लेस्ड इन बिटवीन दिस ऑब्जेक्ट. ह्या ऑब्जेक्टच्या मध्ये किंवा ह्या कॉम्पोनंटच्या मध्ये एखादा डिफेक्टिव्ह पीस ठेवला असेल तर काय करेल तर okay, it is moving in this direction. You just consider, okay, here arrow it is shown. त्या ठिकाणी arrow बघू शकता, कन्वेयर अशा पद्धतीने पुढे मूव्ह होत आहे. तर त्या ठिकाणी काय असणार आहे तर दिस इल्युमिनेटिंग लाईट सोर्स विल इनलाइट द ऑब्जेक्ट. ओके, द फोकस द ऑब्जेक्ट. म्हणजे काय करणार आहे तर हे जे काही इल्युमिनेटिंग लाईट आहे तर त्यावरती जास्त प्रमाणात फोकस पाडण्याचा प्रयत्न करेल. त्यामुळे काय असणार आहे तर इट विल इझिली कॅप्चर द इमेज, डिफेक्टिव्ह इमेज बाय दिस कॅमेरा अँड इट विल पास द सिग्नल्स टू द इमेज प्रोसेसिंग लायब्ररी. ओके, मी काय करणार आहे तर त्या ऑब्जेक्ट जे काय आहे तर त्याची इमेज कॅप्चर केली जाईल आणि ती कुठं पास केली जाईल तर इमेज प्रोसेसिंग लायब्ररीला पास केली जाईल. Now in this image processing library it will compare with the standard specimen. Okay, if it is some defect is occur, then it will pass the signal to this actuator and this actuator move or the remove the object from the conveyor. ओके, एखादं जर ते काय करणार तर इमेज प्रोसेसिंग लायब्ररी मध्ये स्टँडर्ड स्पेसिमेन बरोबर जी काही इमेज आहे तर ती कम्पेअर केली जाईल आणि ती कम्पेअर केलेली इमेज जर बरोबर असेल तर इट विल पास टू द नेक्स्ट कन्वेयर. अदरवाइज इट विल पास द सिग्नल टू दिस actuator and this actuator will move the object from the conveyor. Okay, त्या कन्वेयर वरून ऑब्जेक्ट मूव्ह कर. Okay, this one is the whole process in industry. Just we will see the actual process. I have find out one very good video. Just wait a minute. Okay, first we will understand how our eye is working.
The organ of sight is the eye. Think of it as a slightly irregular, hollow sphere that takes in light and translates it into images. If we enlarge the eye and look inside it, we can discover how that's done. Inside the eye are various structures working together to create an image the brain can understand. Among these are the cornea, a clear dome-like structure covering the iris or colored part of the eye, the lens directly below it, and the retina, which lines the back of the eye. The retina consists of thin layers of light-sensitive tissue. This candle can help us understand how the eye captures images and then sends them to the brain. First, the candlelight passes through the cornea. As it does, it's bent or refracted onto the lens. As the light passes through the lens, it's bent a second time. Finally, it arrives at the retina, where an image is formed. This double bending, though, has reversed the image and turned it upside down. If that was the end of the story, the world would always appear upside down. Fortunately, the image is turned right side up in the brain. Before that can happen, the image needs to travel as impulses along the optic nerve and enter the brain's occipital lobe. When the image forms there, it regains its proper perspective. Now let's consider two common conditions that cause blurry vision. The eye's shape is important for keeping things in focus. With normal vision, light focuses precisely on the retina at a location called the focal point. But what happens if the eye is longer than normal? The longer the eye, the more distance there is between the lens and the retina. But the cornea and lens still bend light the same way. That means the focal point will be somewhere in front of the retina rather than on it. This makes it difficult to see things that are far away. A person with a long eye is said to be nearsighted. Glasses with concave lenses can correct nearsightedness. The lens widens the plane of light coming through the cornea. That pushes the focal point back onto the retina. Farsightedness is just the opposite. The eye's length is too short. When that happens, the focal point is behind the retina, so it's difficult to see things that are up close. Glasses with convex lenses narrow the plane of light. Narrowing the light passing through the cornea moves the focal point back onto the retina and can correct farsightedness.
Okay, I hope you understood our eye mechanism. Okay, how that actually from light source or the image to conversion of image means here also our eyes are the sensors and it will pass the signal to the processing image processing center. Okay, but in human that rays are passed to the brain for processing purpose. Okay, for identification purpose that they are processing. Okay, next one is the vision system or vision sensor are classified as a external non-contact type. They are used by robots to let them look around and find the parts for the example, picking, placing them a appropriate location. Means why it is required. Okay, if it is visions are not there, then what will happen? Okay, जर त्या ठिकाणी जर त्या विजन किंवा कॅमेरा जर नसता तर काय झालं असतं तर त्या ठिकाणी तर टू प्लेस पिक अँड प्लेस एनी ऑब्जेक्ट इट इज डिफिकल्ट विदाउट द विजन. म्हणजे एखादा ऑब्जेक्ट एका ठिकाणून दुसऱ्या ठिकाणी जर ठेवायचं असेल तर त्या ठिकाणी जर विजनच नसलं तर त्या ठिकाणी प्रॉब्लेम क्रिएट झाला. अर्लियर फिक्चर वॉज were used for with robot for accurate positioning of the parts. ओके, एखादं accurate positioning पार्ट करण्यासाठी काय करायला होते तर त्या ठिकाणी they are using some fixtures means okay some guidelines or the guideways are used for the movement of that. Such fixtures are very expensive. A vision system can provide alternative economic solution. Means suppose your robot want to travel from okay one position to the another position. Okay, in that case in previously we are using tracks, okay, like your railway tracks. To move from one place to another place we can put that robot in the track and along that track only it will move. But nowadays okay that tracks or the fixtures are removed with the help of this vision system. Okay, there are different components are there. The robot, okay, this is actually industrial robots you will find. Okay, this one robot object camera for the sensor and a robot controller. This camera will detect whether that robots are working it is correctly or not, and this controller is connected to the our CPU or the processing unit of our computer, and accordingly it will take the decision whether that robot will move further or that robot want to pick that object. Okay, just we will see okay the components of robot will understood.
You create.
Welcome to Microscan's Introduction to Machine Vision, an educational webinar series to help new users better understand the basics of machine vision technology. This is the first installment in our series, and over the next 10 minutes or so, I'm going to talk about what machine vision is and how it's used in factory automation, along with the 4 most common applications of the technology. So let's get started with a definition of machine vision. Machine vision is defined as the automatic extraction of information from digital images. So what exactly does that mean? Well, let's look at a very basic breakdown of a typical machine vision process. First, you have a manufacturing production line with a steady flow of objects. Then you have a camera or optical system trained on the line. Next, you make sure that you have proper lighting of the line so the camera can see the necessary details. The camera captures digital photographs and analyzes the images against a defined set of criteria. That's in an industrial context. There are different types of vision that are used for other purposes, but when we refer to machine vision, we're talking specifically about industrial vision as it's used in a manufacturing environment. Manufacturers use automated machine vision instead of human inspectors because it's faster, more consistent, and works for longer periods of time. Vision technology got its start in the 1950s, but the widespread use of machine vision in industry arose in the 1980s and 90s. This photo, taken from the Wikipedia entry on machine vision, shows a pioneering demonstration at a 1983 trade show of a system by Automatics, which is now part of Microscan. Of course, machine vision has come a long way since then and is now used for many different valuable processes in manufacturing. Let's talk about some of the most common applications of machine vision. As it has developed, machine vision's applications have grown into 4 basic functions: measurement, counting, location, and decoding. Since its start, machine vision has been widely used for measurement. And by this, we mean the automated measurement by a machine. That measurement can then be checked to a specified tolerance. For example, something we've been doing for years with machine vision is measuring the gap in spark plugs. As you may know, this gap needs to be a certain width, or the car won't run as well. Therefore, this gap measurement is an extremely critical spec for the part. We can use a camera and measure the spark plug gap by machine. This eliminates the need for a person to be there to measure and adjust the gap manually. We can automate the process and do it more quickly and accurately. Counting is another typical machine vision application. There are a few different tasks that fall under this category, but basically, counting means to look for a number of parts or a number of features on a part. This allows us to locate missing parts and ensure that products are assembled properly. This example shows an aluminum flange with some holes drilled in it. If you count the number of holes, you'll see that there are exactly 8 of them. Assuming that we wanted 8 holes, we know that the drilling process was done properly. Another counting function is absence, presence. Is it there or not? Here we have an 8-pack of sodas, and you can see that one of the sodas is missing. With machine vision, that packaging can be checked to make sure an incomplete pack doesn't make it to the grocery store shelf. We've slowed the process down so you can see it, but machine vision systems can operate much faster. Location is when machine vision is used to report the position and orientation of a part. This may be done for several reasons. We can locate the position and orientation and then check that to a specified tolerance. So in other words, you're looking at the part to make sure that it's at the correct angle and using that as a reference point to verify proper assembly. You can also use this for alignment to other machine vision tools. Let's take our spark plug example. This is a very powerful feature in machine vision. Your parts may be facing all different directions as they go down your production line. And you can locate a part, straighten the image, and then you can run other machine vision processing tools on it. Additionally, you can find a unique pattern and use that to identify a part. An example you can see here is a can of soup. The vision system has been trained to look for a pattern on the soup. In this case, the portion of the label that says tomato on it. We can use that pattern to verify that we do, in fact, have the right soup going down the line. Decoding refers to the decoding of 1D and 2D symbologies, such as linear barcodes, stacked symbologies, as you see here, and 2D symbologies, such as data matrix codes. This also refers to OCR, or optical character recognition, which is text that is simultaneously human and machine readable. Decoding is typically used to record information as historical data. That way you have a record of parts that have gone through a process. You can track the path that a part took through that process and use that data for immediate action, meaning that you can look at the data and sort based on what it says. You can also validate the data for correctness. When you read a marked code on an object, you can verify that the data in the mark is correct, or that the format of the data is correct, or that you have the correct product going down a production line. An obvious question here is, why use machine vision to do this when dedicated auto ID systems would do the same thing? You might think of machine vision as auto ID or barcode reading plus. The plus is the ability to run other measurements and operations in combination with the reading of barcodes or text. For example, you might want to read a label and also check that it's properly aligned to the product. In other cases, you may need the ability of a machine vision system to tackle tougher applications that require more capability in terms of image pre-processing, or in the case of a PC-based system, sheer speed and processing power. An example of this sort of application is reading the OCR code on a can of vegetables during a high-speed canning process. You may not realize that when vegetables are put into cans, they are usually done so with no labels, and the only indication of what's inside is a text code on the end of it. When the time comes to put the label on the can, a vision system checks the code on the end of the can to make sure that the right vegetable is inside the can and matches the label. So let's review. Machine vision is the automatic extraction of information from digital images. And we talked about the common manufacturing applications of machine vision, which generally fall under 4 basic functions: measurement, counting, location, and decoding. The visual examples we've shown you here are mostly slowed down so you can see what's happening. In reality, machine vision can operate much faster, processing hundreds, or in some cases, even thousands of pieces per minute. But that's just one of the many reasons manufacturers are using machine vision. Be sure to check out the next
Okay, I hope you understood that one. Application where we can use this for measurement inspection purpose. We are going to discuss in next slide. Okay, before that only you may understood that part. सगळ्यात लक्षात आले की आपण विजन सिस्टीम हे इन्स्पेक्शन साठी यूज करू शकतो. त्यानंतर आपले मेजरमेंट असतील. सपोज यू वांट टू मेजर ऑफ लेंथ ऑफ एनी ऑब्जेक्ट in production line, then also we can use that. Okay, this one is actually our system where we can use our vision system. Okay, the components of vision. Other task of vision system used with a robot, including the following. Okay, for inspection purpose, now only we have discussed. Okay, for inspection purpose we can use these robots. Okay, sorry, vision systems in robotics. Checking for a gross surface defect, discovery of flaws in the labeling, verification of the presence of component in assembly. Okay, means in assembly to find the defects like gross surface or the flaws inside that assembly, to find that for inspection purpose we can use such a vision sensors or the cameras, or the we can say that video record. Measuring or the machine vision, we can say measuring for a dimensional accuracy, checking the presence of hole and other features in a part. Okay, now only we have seen in that video how that presence of hole. Suppose in your part one disc is there. On the disc, okay, you have to drill 4 holes, and by mistake you have drilled the 3 holes only. In that case also this vision system reject that part. Okay, and previously it is manually we have to check out whether they have drilled 4 holes or the 3 holes. Okay, depend upon rejection we can do. But nowadays we can use the vision system for rejection purpose, or to find the defects inside that. Next, identification. Here the purpose is to recognize and classifies an object rather than to inspect it. Inspection implies that the part must be either accepted or rejected. म्हणजे त्या ठिकाणी काय असणार आहे तर आयडेंटिफिकेशन. अगेन द every person is unique, and that person having its own identity. Okay, त्याचं जर बघितलं तर सपोज राम आणि श्याम 2 विद्यार्थी, तर दोघांचेही चेहरे एकसारखे कधीच असणार नाहीत. ओके, त्यामध्ये थोडं तर चेंज असणार. मीन्स that person having unique identity. That unique identification we can do with the help of this vision sensor. Next, visual surveying and navigation control. Now we have seen to navigate also we can use this vision system. Means to project आता नेव्हिगेशन सिम्पली बघायचं झालं तर आपल्या ह्युमनला जर बघितलं तर डोळे, जर डोळेच नसते तर नेव्हिगेट झालं असतं का? नेव्हिगेट मीन्स टू मूव्ह फ्रॉम वन प्लेस टू अनदर प्लेस. तुम्ही मूव्ह झाला असतं का? तर मूव्ह झाला नसतं तर त्या केसमध्ये मग त्या ठिकाणी काय करायला लागलं असतं तर You have to take the help of another any support. Okay, कुठल्या तर दुसऱ्या गोष्टीचा तुम्हाला सपोर्ट घेणं गरजेचं पडलं असतं. The purpose here is to direct the actions of the robot based on its visual inputs. For example, to control the trajectory of the robot's end effector towards an object in the workspace. Industrial application of visual surveying are part positioning, retrieving part moving along a conveyor, seam stacking in the continuous arc weld. Okay, all above the application some way required the determination of the configuration of the object motion of the object, reconstruction of the 3D geometry of the object from their 2D images of the measurement, building the maps of the environment for the robot navigation. Means now you can see here, okay, we can use many more application where we can use the vision system, like reconstruction of 3D geometries or the preparation of geometries, motion of the object. To identify these many things, we require the vision system. Coverage of vision system is from few millimeter to 10 of meter. त्या ठिकाणी काय करू शकतो तर मॅक्झिमम आपण काय करू शकतो तर we can keep the vision of up to the 10 meter and up to few millimeter we can see that. ओके, ज्या पद्धतीने आपल्याला डोळ्यांनी एकदम जवळ आणि लांबचा जर विचार केला तर त्या पद्धतीने आपल्याला with the help of cameras also having some capacity to capture the image. आता जर एखादी इमेज 10 किलोमीटर वरती असेल तर ते कॅप्चर करता येईल का? येणार नाही आपल्या त्या ठिकाणी. मग त्या केस मध्ये काय करणार नाही तर अप टू मॅक्झिमम रेंज दे हॅव डिसाइडेड अप टू फ्यू मिलीमीटर टू 10 मीटर, म्हणजे मॅक्झिमम 10 मीटर पर्यंत आपण त्या ठिकाणी वी कॅन कॅप्चर द इमेज. मीन्स झूम इन झूम आउट. Okay, that features comes under this with either narrow or the wide angles depend upon the computer vision or the computer graphics. Computer vision can be taught as a inverse computer graphic. Okay, means computer vision is the inverse of computer graphics. Computer graphics deals with how to generate image from a specification of visual scenes. Okay, these graphics are very important for generation of images. Okay, like might be you have seen, okay, those computer having graphics cards, the images or the games you will play with better interactive manner as compared to without graphics card. Okay, that is the function of graphics card only to generate the image with high resolution, whereas computer vision invert this process to infer the structure of the world from the observed images. System needs and design, okay, shown a typical visual system connected to an industrial robot. Okay, this figure means this one figure. Okay, you will understood. Okay, actually this system are generally used in industrial sector. You will find in industrial sector. Now, which are the elements in the our vision sensor? आता कुठले कुठले elements असतात तर now just we will see. Okay, our first element of vision sensor is object. Object means the surrounding object which we want to capture the image. म्हणजे एक ऑब्जेक्ट लागेल आपल्याला, हे तर कन्फर्म आहे. मी जे जी फोटो काढायचा तर तो ऑब्जेक्ट आपल्याला असणं गरजेचं आहे. Light source we need. Light source, if you take the picture from the camera, okay, suppose in front of you something is there, something object is there, okay, तर त्याचा तुम्हाला जर फोटो काढायचा असेल तर लाईट मॅक्झिमम लाईट सोर्स असणं गरजेचं आहे. तर तुम्ही जर बघितलं असेल तर डार्क रूम मध्ये काढलेला फोटो आणि बाहेर सराउंडिंगला लाईट सोर्स मध्ये असलेला फोटो, विच वन हॅव्हिंग द मोर क्लॅरिटी, you will definitely get the, okay, the light have, okay, ज्या ठिकाणी लाईट आहे त्या ठिकाणी जर ऑब्जेक्टचा फोटो काढलेला असेल तर त्या ऑब्जेक्टची क्लॅरिटी जास्त असेल. नेक्स्ट रिफ्लेक्टेड लाईट. ओके, दॅट रिफ्लेक्टेड लाईट it will pass to the shutter. Okay, shutter means आता तुम्ही जर आपल्या ह्युमन बरोबर कम्पेअर केलं तर शटर म्हणजे कुठले आहेत? ओके, विच वन इज द शटर ऑफ आवर ह्युमन आय? यस, जे काही पापणी किंवा आपण डोळ्यावरची जी काही झापड म्हणतो ते म्हणजे काय तर आपलं शटर आहे. नेक्स्ट लेन्स. व्हाय इट इज रिक्वायर्ड लेन्स? लेन्स का गरजेचं आपल्याला? टू कन्वर्ट ओके दॅट इनटू द one focal distance. Okay, the concentrate all rays into single point, we require the lens. Okay, आपल्याला बाहेरच्या सगळ्या जे काही रेज आहेत ते कॉन्सन्ट्रेट करण्यासाठी आपल्याला काय गरज बसणार आहे तर आपल्याला लेन्स असला. अगेन sometimes we require concave or the convex lens depend upon the position of the object. ऑब्जेक्टच्या पोझिशन वरती आपल्याला काय असणार आहे तर ते कॉन्केव्ह लागणार आहे का कॉन्वेक्स? इन आवर आयज वी कॅन ओके सम हॅव्हिंग डिफेक्ट्स इन द आयज, देन इन दॅट केस ओके डॉक्टर विल सजेस्ट डिपेंड अपॉन द डिस्टन्स he will suggest you can use the convex or the concave lenses for your eyes. Okay, glasses you can use those having the concave or the convex lenses. म्हणजे त्या ठिकाणी बऱ्याच जणांना जवळचा किंवा लांबचा नंबर असेल तर त्या केस मध्ये काय डॉक्टर सजेस्ट करतात तर यू कॅन यूज द ग्लासेस. ओके, glass having the convex or the concave means to concentrate all the rays and it will pass to sensor. Okay, लेन्स मधून पास झाल्यानंतर कुठे येणार आहे तर सेन्सर. सेन्सर हॅव्हिंग टू पार्ट्स. ओके, वन टायमिंग अँड द एनालॉग electronics. Okay, and after that it will pass the signal to the our memory. Okay, this one is the actual structure of the elements of our vision sense. Now in vision system the principal image component is a complete camera including sensing array, associated electronics, output signal format and lens as shown in figure. The task of the camera as a vision sensor is to measure the intensity of the light reflected by an object as indicated in figure 4. Okay, the previous figure, okay, that only the elements we have seen and intensity of light reflected by the object, this must be there. Using a photosensitive element, trimmed pixels of the photo sites. Okay, means the photos are captured in the form of pixels. Okay, pixel is capable of transforming light energy into electrical energy. The sensors of different type like CCD, CMOS are available depend on the physical principle exploited to realize the energy transformation. Means the CCDs, CMOS, okay, these are the some types of okay our camera. We are going to see in detail this in the next PPTs. Okay, depend upon the application. You just remember CCD and CMOS are the two cameras. Okay, with the help of that cameras we can convert that pixel capable transformation of light energy into electrical energy. Okay, depend upon the application. The camera should be RS 170 CCIR. These are the American 170 monocolor, European Indian CCR monocolor. Okay, these are the some monocolors. With the help of that it is capturing progressive scan, variable scan or line scan. Okay, we are seeing also this okay variable scan or the line scan, how it is done okay separately in detail. 5 major system parameters which govern the choice of camera are field of view, resolution, working distance, depth of field and image data acquisition rate. Okay, means depend upon these 5 parameters only we are choosing or the selecting any camera. ओके, तर तुम्ही जर एखादा मोबाईल सिलेक्ट करत असेल आणि त्याचं कॅमेराचं जर बघितलं तर जनरली वी आर सीइंग ओके त्या कॅमेऱ्याचं काय बघता तर आपण रिझॉल्युशन किती आहे ओके, त्याचे वर्किंग कसं आहे. ओके, इट इज वर्किंग विथ सिम्पल ऑर द हॅव्हिंग सम कॉम्प्लिकेशन आणि द डिस्टन्स. आता किती लांबचा डिस्टन्सचा तो फोटो कॅप्चर करू शकतो. डेप्थ ऑफ फील्ड मीन्स अगेन प्रोसेसिंग, किती कशा पद्धतीने प्रोसेसिंग करतोय. ओके, मीन्स यू हॅव सम ब्युटी प्लस अँड अदर फीचर्स इनसाइड दॅट. ओके, डिपेंड अपॉन दॅट. ॲज अ रूल ऑफ थंब फॉर साइज मेजरमेंट, the sensor should have a number of a pixel at least twice the ratio of largest to smallest object sizes of interest. Means depend upon the object size. Okay, it is generally they have pixel size, it is twice of the object. Okay, next, camera system. Okay, how that camera system it is actually working, just we have seen as indicated in that figure. Okay, previous figure, in this figure we have seen the components of that one. A camera is a complex system comprising several devices inside it. Other than photosensitive sensor, they are shutter, a lens, analog processing, electronics. ओके, म्हणजे त्या ठिकाणी जर बघितलं तर त्या एलिमेंट्स ऑफ आवर कॅमेरा इनसाइड दॅट फक्त फोटो सेन्सर आहे का, तर त्या फोटो सेन्सर बरोबर ओके यू विल फाइंड अदर पार्ट्स लाईक शटर, लेन्स अँड अॅनालॉग प्रोसेसिंग, इलेक्ट्रॉनिक डिव्हाइसेस. नेक्स्ट, द लेन्स इज रिस्पॉन्सिबल. आता लेन्स कशासाठी यूज करतोय बघूया आपण. द लेन्स इज रिस्पॉन्सिबल फॉर फोकसिंग द लाईट रिफ्लेक्टेड बाय ऑब्जेक्ट. ओके, लेन्स काय करणार आहे तर now only to capture that image, okay, or focusing the light reflected by the object on the plane where the photosensitive sensors lies called the image plane, in order to use it to compute the position and orientation of an object. Associated coordinate transformation need to be performed using knowledge of chapter, okay, that is transformation. This is generally carried out by software residing inside a personal computer which save the image. Specified calculator related camera calibration can be found in, okay, these are the scientists note that there are two types of video cameras, analog and digital. Analog cameras are not in common anymore. Now might be you have seen the analog and digital camera. Okay, can anyone tell me in our mobile phone which one is the camera is available, whether it is analog or digital? आपल्या मोबाईल मध्ये जे यूज करतात ते अॅनालॉग यूज करतो का डिजिटल? yes, anyone? If you have seen the features and which one is the analog, have you seen that analog cameras? Yes. Can anyone tell me which one is the camera, whether it is analog or digital camera in our mobile phones or the smartphones? Smartphone मध्ये कुठले आहेत आपले कॅमेरा? Yes, anyone? Okay, analog camera are those camera which is used in previously. Okay, पाठीमागच्या वेळेस जे फोटोग्राफर यूज करत होते. Okay, one strip is there, on that strip, okay, negatives are printed and that from negative it is generating the pictures. Okay, त्या negative पासून काय करत होते तर picture generate करत होते. Okay, that are at it is analog, and digital means by conversion. Okay, that photos are conversion in the form of pixels only, pixels. Okay, we can say that these are the, you can, okay, videocon camera. Okay, this is again one type of camera. Early vision system employed videocon camera which were bulky vacuum tube device. They are almost extinct today, but explained here for the sake of completeness in the development of video camera. Videocons are also more sensitive to electromagnetic noise interference and require high power. Their chief advantage are high resolution and better light sensitivity. This figure shows the schematic diagram of videocon cameras. Okay. Now previously, okay, this type of the videocon cameras are, these are the analog, we can say that. Here, one frame, transparent metallic frame. Okay, this one is the lens. After that, transparent metallic frame, photosensitive mosaic. Okay, this one is the our that strip of photo where we want to generate the negative, and behind this the capacitive deflectors and the electronic gun. Okay, when we click on that button, okay, it will generate the, okay, it will generate the focus, and depend upon that it will generate the negative on the this photosensitive plate. Okay, might be you have seen in previous days the analog camera it is used. Okay, inside that rolls are attached, and depend upon that roll only the negatives are generated. After that processing that negative, it will, okay, it will generate the photos. Okay, ते photos त्या ठिकाणी generate केलेले तुम्ही त्या ठिकाणी बघू शकता. In simple sampling, a given analog signal is sampled periodically to obtain a series of discrete time analog signals as illustrated in the above figure. By setting a specified sampling rate, the analog signal can be exploited by the simple digital outputs. However, while reconstructing the digital signals from the sample data, one may end up with a completely different signal. This loss of information is called aliasing, and it can be seriously problem. In order to prevent aliasing, according to the sampling theorem, the sampling rate must be least twice the largest frequency in the original video signal if one wish to reconstruct the signal exactly. Okay, this one is the sampling and digitalization. Okay, in sampling you will find, okay, in analog signals it is in the sine waves, but here you will get it is in a square waves in digitalization. Okay, it is similarly fine and more accurate. Next, a digital camera, we can say that digital camera means inside that some charge coupled devices are attached, and or it is also known as CCD. A digital camera is based on a solid state technology. The main part of this camera is a solid state silicon wafer image area that has hundreds of thousands of extremely small photosensitive areas called photosheets printed on it. Each small area of the wafer is a pixel. As the image is projected onto the image area, at each pixel location of the wafer, a charge is developed that is proportional to the intensity of the light at the location. This digital camera is also called as charge coupled device camera or charge indicated device, CID cameras. Okay, now we have discussing that CCD and, okay, and that are generally which materials we are using, solid state silicon wafers. Okay, these are the used for this charge coupled devices. The collection of charges is if readily sequential would be a representation of the image pixels. The output is a discrete representation of image as a voltage simple in a time. Solid state camera are smaller, more rugged, last longer, and have less inherent images can distortion than Videocon camera. They are also slightly more costly, but prices are coming down. Nowadays, you can find digital camera having the prices lesser and lesser. Okay, these are the, okay, this one is the silicon strip. Inside that, these are the electrons. Okay, small. Okay, and that electrons, okay, are charged with different elements. Okay, both CCDs and CIDs. CCDs means charge coupled device and charge integrated device. Okay, you should remember this. Charge coupled device and charge integrated devices. Chips use large transform technique to capture an image. Okay, these charges are stored and depend upon charge, it will generate the image. In the charge, okay, chip device, camera, light impinging on the optical equivalent or random access memory chip, RAM chip. This light is absorbed in the silicon substrate with charge buildup proportional to the amount of light reaching the array. Once a sufficient amount of energy has been received to provide a picture, the charge are read out through built-in control registries. Okay. Now, some of the you will find this. These are the basic principles of CCD, and these CCDs are it is used in our digital cameras. CCDs are the charge coupled devices, or the we can charge integrated devices. Okay, we can say that. Okay. Next one is the some CCD chips use an interline charge transform techniques. Other use frame transfer approach, which is more flexible for varying the integration period. The CID camera works on a similar principle. A CID chip is a metal oxide semiconductor based on a device with multiple gates similar to CCDs. The video signal is the result of a current pulse from a recombination of carriers CID products. What is a pixel? A pixel is a short form of picture elements. Means the charges which is stored in that strip. Okay, electronic strip. And that is nothing but we can say that pixels. It is a single point in a graphic image, a better image, and use a different readout technique that CCDs, which required a separate scanning address unit. Okay, charge coupled devices are therefore more expensive than CCDs. The principal difference between CCDs and the CID camera is a method of generation of video signals. Okay, these are the name itself you will understood. CCDs charge coupled devices, CID you will understood charge integrated devices. Okay, the name itself it will differentiate and depend upon the differentiation it will generate the video signals. Okay, now we'll go to the some of the introduction of a machine vision system. Yeah, time is over. Okay, we'll take this part in the next lecture. If you have any query up to this, you can ask. Otherwise, you can write your roll number in chat box and you can leave the meeting, no problem. हॅलो सर आलं की हो